Alright, so integration, we're going to look at main forms that you're going to be looking at in both your extension courses. So we're doing just extension 1 to get us going now, is going to be involving a form of substitution. Okay, so the majority of the integrations you do will have some form of substitution you need to make. Okay, because looking at that as it is, okay, we can't integrate that as it is. Okay, so we can differentiate using the product rule, okay, but we can't integrate using the product rule as it stands with the skills that you know at the moment. Okay, so once we get through this section, which will be up to your last lesson, essentially before your assessment, okay, is making some suitable substitutions so that we can integrate, okay, by considering along the lines of the chain rule. So, find the integral of 3x squared outside of x cubed plus 1 all to the power of 4. Now, we could expand all this and use binomial theorem, use binomial theorem to expand all this and then integrate your like term, but that's going to take time, okay, etc., etc., okay. So when we make a substitution, often it reduces the work. Now, in your syllabus, it says that they will give you the substitution, okay? So they will tell you what you need to make the substitution for, alright? So that will help you guys. So, if u is x cubed take away 1, okay, and that will be some part of the function that you need to integrate, okay? So what we're going to do is we're going to differentiate du differentiate u with respect to x, okay? So yes, we are differentiating. So, 3x squared. What I'm going to do is I'm going to replace bits and pieces of this with what I'm working through now. Okay? So, if I replace this part, that will be replaced with u, so that becomes u to the power of 4. Alright? And I've got 3x squared. Okay? So I'm going to do a replacement with that. So du is equal to 3x squared dx, so just bring that up to that side, it's your fraction skill. And here I've got 3x squared dx. Alright, so what I'm going to do is then dump all that into that, and I'm going to integrate with respect to u. So the integral of 3x squared x cubed take away 1 dx is going to equal the integral, so 3x squared dx is du. This, all to the power of 4, so u is that, all to the power of 4. So, everything now is in terms of u. Okay, so this is u to the power of 4, 3x squared dx is du. So then I can integrate with respect to u. And that's much more straightforward for me to integrate, considering your previous skills. So, u to the power of 5 over 5 plus our constant of integration. And then the last thing you need to do is replace u's with what x was. Okay, x cubed take away 1. And that is the integral. Okay, so remembering, when we differentiate what we've integrated, we should get the same answer. Okay, so let's have a go. So we differentiate this. So we've got x cubed take away 1 all to the power of 5 over 5. We do d dx, okay, so remember we take down the power. X cubed. So 5 outside of x cubed take away 1 to the power of 4. Okay, still over 5 from the denominator, and we multiply by the derivative, 3x squared. Okay, so the 5s and 5s cancel, and I've got back my original function. Okay, so you can always check your integration solution by differentiating what you get, what you've integrated, okay, and you should get the same answer from the beginning. Alright. Second one. The integral of x outside of 1 plus x squared, the square root of 1 plus x squared, and we make that substitution. Okay, so the substitution will usually be some part of your function. Okay. So, we need to do a du dx from the substitution, so you need to differentiate that. Okay, so when I integrate 1 plus x squared, I get 2x. Alright, so in the actual function, I've got x and dx. Alright, so I've got du is equal to 2x dx. Okay, so if I've got x and dx, right, I need to move this 2 back over here. So du over 2 is equal to x dx. So then I can substitute that straight in. And 1 plus h squared I replace with u. So it becomes the square root of u. Alright, so the differential of x square root of 1 plus x squared dx. So I've got x dx. So x dx I'll replace with du over 2. And then the square root of 1 plus h squared I'm going to replace with the square root of u. Okay, so we're following somewhat the process. Somewhat. Okay, so half. So use 3 over 2. That would be 3, 2, no, 2/3, sorry. So 2 u to the power of 3 over 2 over 3. Plus our constant integration. Okay, so the halves cancel. Okay, so the last thing we need to do is go replace u with what I made the substitution for. So it'll be 1 plus x squared square root of 1 plus x squared all to the power of 3 using the index laws. All over 3 plus our constant integration. Okay, so if I then differentiate that, should get this again. Okay, and that's the whole process of it. Alright, any questions before I do the next one? Okay, so you're understanding? Somewhat? Yeah, do you need to ask anything? Square root, sorry?
The square root bit?
From here or here?
Yeah.
That one? Is 3 over 2.
Oh, it's 3 over 2.
Yeah.
No, I thought it was to the power of 3. And like x squared and x cubed makes 6.
Okay, so now clarify what you're doing here. Sometimes they come in fraction forms as well. So, integral of x plus 1 all over x squared plus 2x to the power of 3. Using substitution, u equals x squared plus 2x. Okay, so that's where you start. This will probably be 2 marks. Okay, so the first mark will come from your du dx and setting that all ready to go. And then your second mark will come from the integration once you've done substitution. Okay, so do a du dx. So we'll differentiate that. So we have 2x plus 2. Okay, so far, x squared plus 2x, what's inside that bracket is going to get replaced by u, because that's my substitution. Okay, then I need to do something with what's up the top. Alright, so I've got x plus 1 dx on top. Alright, so du is going to be 2x plus 2 dx. So I need x plus 1 and dx. So I can make the substitution. So at the moment I've got 2x plus 2. Okay, adding factorise, okay. 2x plus 1 dx. So du over 2. So what you're writing here is what you need to replace inside the rest of your integrand. Okay, so x plus 1 dx is going to get replaced by du over 2. So an integral of x plus 1 over x squared plus 2x all to the power of 3 dx. Right, so x plus 1 dx, I'm going to replace with a du over 2. So I'm going to write the half out the front because it's going to be a constant. Dx left on top. Du, sorry. And on the bottom, x squared plus 2x was u. So on the bottom, I'm going to have u cubed. Alright, so using my index laws, 1 over u cubed is going to be u to the power of negative 3. Okay. To add 1, divide 1 new power. And negative quarter, sorry, negative 1 over u squared plus c. And then the last thing you need to do is replace u for x. U squared plus 2x. So again, if I differentiate that, I should get back to what I was integrating from the first place. Right, so this is some of the stuff you'll also, this is basically the stuff you'll see in extension 1, a couple other things you need to do with integration, right, but this forms a foundation for extension 2 integration. Right, any questions? Alright, we're getting this. Alright, so let's make that. So as it stands at the moment, if we don't make a substitution, we don't actually have the technique to be able to integrate that. We can't just do the opposite of the product rule for differentiation. Okay, doesn't work that way. So we need to have other skills to be able to integrate. Right, so the first thing you need to do, du dx is going to be negative 1. Okay, so dx, negative du, sorry, negative u du is dx. So I've got that one, replace that with a negative du, okay. I know what 1 plus x, I can replace that with u, but I have a problem. I've got x out the front. Right, any suggestions what I'm going to do? Rearrange that for x. Okay, so now I have an expression for x in terms of u. Okay, so everything needs to be in terms of u when I do that. Okay, so sometimes you have to rearrange your substitution so that you can replace. Right. Now instead of rewriting that, I've just remembered capital I for integrand. So instead of rewriting this, right? So dx is going to be replaced by negative du. square root of 1 take away x is going to be replaced with the square root of u, and x is going to be replaced with 1 minus u. So negative integral of x, 1 minus u, and the square root. Okay, and I can actually do an expansion now because I can't do the expansion here because of the surd involving more than one term, but here the surd only involving one term. So I can actually use my index laws to finish the question. So we square root of u, take away, multiply, you add them, so we u to the power 3 over 2. Okay, and we can integrate that. Alright, we can integrate when we have addition and subtraction. Alright, so negative u to the power 3 over 2. Right, so just in combining my index clauses, etc. Right, you might need to do another step. Okay, so essentially this is u to the power of a half. Integrate that, you get u to the power of 3 over 2 over 3 over 2. Okay, so I'll just rearrange as I've gone. U to the power of 3 over 2 plus 1, there will be u to the power of 5 over 2. Five over 2, so it'll be 2 and 5 here. And because of the indefinite integral, you need to add your constant integration. Right, if you stop there, you probably won't get your full marks because it was an integration in terms of x. Alright, so you need to actually go back and replace u with 1 take away x. Alright, so I'll just expand it as well. Okay, you can watch your signs as well. Okay, because I've taken the negative right at the very front. Okay, you can leave the negative in the integrand if you wish. Whatever works for you. Right, questions there? Right, so sometimes we don't have an integrand involving t's, x's, we've got other variables that we need to consider as well. Same process. Right, so this one's in t's. Usually the substitution is to u equals, okay, not always. So you just got to be careful. Right, so they told you to do the substitution. So instead of writing du over dt, alright, I'm just going to incorporate that next step. So differentiate this, I'm just going to get 1. So 1 lots of dt. So when I differentiate du with respect to dt, when I do a du dt, so differentiate u with respect to t, I get 1. So I can just write it in one line once you get the idea what's going on. So I can replace my t's with u's, du's. Alright, I can replace what's inside the surd with u. And again, I've got this variable up here I need to deal with. Alright, so I'll go back to my original substitution. So t is going to be u take away 1. Alright, so capital I for integrand is going to be, so dt gets replaced with du, t on top of the fraction is u take away 1, and the square root of u on the bottom, and du is what I'm integrating with respect to. Alright, what do I do from here? Can I integrate that as it is? What do I do then? Okay, split up your fraction so that you can do each part. Right, so u to the power 1 divided by the square root. So you've got a division, do a subtraction of your powers. Okay, so 1 take away half, half. Okay, and then your index clause becomes u to the power of negative a half. Right, so now I can integrate. Okay, so if you're not confident with what I've just done there in terms of getting straight to that step, okay, you need to go to a middle step. Yep.
With u over root u.
So?
With u over root u.
Yes.
U to the power of 3 over 2.
It's that, and then I'll integrate.
No, from u over root u
Yep.
to u over 1 over 2.
Well, it was u to the power 1 take away, u to the power 1 over u to the power of a half, using your division index clause to be 1 take away a half. Yep.
It makes sense, but like you wouldn't think to get that. You wouldn't think to get u over root 2 because u 2 power of a half. So that's only going to be root u.
Well, thanks for your share. Well, you think about it, if I rationalise this and multiply it by root u on top and bottom, you get u root u over u. Yep. So the last thing you need to do, and also making sure if there are surds in the question, surds are in the answer, okay? So what is it, 1 plus t, 2/3 square root of 1 plus t cubed, take away 2, don't need the bracket anyway. Okay, so if I differentiate that, I'll get what I integrated to begin with. Okay, so that will be a way to check your answer. Okay, any other question? Alright, the integral of 3x take away 5 to the power of 4 dx using that substitution. Okay, so again, we could use our binomial theorem and have our 5 terms and integrate our 5 terms. Okay, however, in the exam they'll be asking you to integrate using this substitution. Okay, so if you don't do this, then you won't get your full marks. Okay. Right, so du is going to be 3 dx. Right, so once you sort of get your patterns, you can write things down a bit quicker. So, I've got dx here, so I'm going to make the substitution. Alright, so I'll just need dx by itself, so it'll be du over 3 u dx. Right, and I've got everything I need because it's just a function. A binomial expansion. Not a binomial, polynomial. So, it's going to be 1/3 the integral of u to the power of 4 du. Okay, so you just got to watch what happens when you have constants as well, and you can move those constants right out at the beginning of your integrand. So, 1/3 u to the power of 5 over 5 plus our constant integration. So it'll be 3x take away 5 to the power of 5 over 15 plus our constant integration. Right, got the hang of it? Alright, do you want to try some for yourself or you want me to keep going? Yep. it's more or less the same thing, but an extra step. Yep. Because